At Materials at Extremes, we study the mechanics of materials in extreme environments. We advance, print, and manufacture new materials. We perform really cool testing experiments in our lab, gathering information about how they perform at elevated temperatures and mechanical loads. And then we model that data and develop new equations that describe how they respond. One of the coolest projects that we've got coming online is 3D printing metals in the vacuum of space. If we are to become a space traveling civilization, we have to be able to repair our spacecraft. Now, imagine a mission to Mars. Imagine that mission takes, say, 18 months. And halfway along that mission, a critical component fails. What are the astronauts to do? You can't come back home, you can't just turn the car around and get back home instantly and go to a shop and get it repaired. You have to be able to create those parts on the fly. But also there's the idea of satellites. Right now there's constellations of dead satellites orbiting the Earth, becoming obstacles to further space exploration. What if instead we could service those spacecraft? What if we could bring the repair shop to the spacecraft, we can open it up, diagnose what's wrong, and print on the fly the components needed so that satellite can function again. So there's a lot of potential applications for 3D printing metal in space. One of the biggest challenges is power. How do you fuse metal into a component? A lot of the techniques on Earth use lasers or electron beams, high energy methods, and there's only so much energy storage you can have on, say, the International Space Station. So what's needed is a method that has a low energy consumption. Another issue is just microgravity. If you were in microgravity and you were trying to fuse something, it likes to form as a sphere rather than deposit in a nice uniform layer. So you need a technique that can deal with the shape change under a microgravity environment. And then finally, probably one of the most critical things is when you're trying to make a metal part, often you're using fine metal powders. We don't want these fine micron and submicron sized particles getting trapped in their lungs or becoming an environmental or a health hazard on a spacecraft. So there needs to be techniques that deal with those types of challenges. So here at MADX, we are using a new technology called bound metal deposition. This allows us to print metal using a polymer printer, which requires very little energy and is appropriate for space, for the space station. Once we've created our composite of a metal and a polymer, we then need to burn out that polymer and leave a 100% metal part. Now, how do we do that? We use a vacuum furnace, or we use the vacuum of space. We use energy, a low energy process. That polymer vaporizes out, and then we fuse the metal that's left behind, giving us a dense metal part. Next steps are to perfect the recipe, but also to put in a proposal to the International Space Station National Lab. Because we see this technology, the next logical step is to leave the laboratory and go to orbit.